I want to explain three concepts that I end up using over and over in this course. The first is the bijection principle. If there is a bijection between two finite sets, then they have the same cardinality. The second idea is the addition principle. It says that if you have a set A, which is the union of a bunch of disjoint sets, then the cardinality of A is the sum of the cardinalities of the disjoint sets. The third principle is called the multiplication principle. It says that if B is the set of tuples, where the ith entry of the tuple is from the set AI, then the cardinality of B is equal to the product of the cardinalities of the AI. Let me give an example of how these three principles are used. It's simple, but hopefully it demonstrates how they are used quite subtly. Say that we want to argue that the number of subsets of the integers 1 through n is equal to 2 to the n. We note that every subset S can be represented by a tuple of zeros and ones, A1, A2, up through AN, where AI is equal to 0 if I is not in S, and AI is equal to 1 if I is in S. That is, I'm saying that there's a bijection between the set of subsets and the set of tuples of length n consisting of entries that are either 0 or 1. So, they have the same cardinality, and by the multiplication principle, there are 2 to the n such tuples because each entry AI has exactly 2 possibilities. Now let's go one step further and define CNK as a symbol which represents the number of subsets of 1 through n with exactly k elements. Since the set of all subsets of 1 through n is equal to the union of the subsets of 1 through n with k elements, where k ranges from 0 to n, and because these sets are disjoint, then by the addition principle, it says that 2 to the n is now the sum of CNK, where k ranges from 0 to n.